Hi guys, and welcome to this episode on how to handle missing data. If we don't handle missing data appropriately, this can impact the performance of our models. It is important therefore that we are made aware of the different techniques available to handling missing data. Handling missing data is usually not our end goal, but is involved in the pre-processing steps and can be used to improve model performance. In this episode, I look to explain the methods we can use to handle missing data and the advantages and disadvantages of each method. There are three types of missing data: missing completely at random, where missing data has nothing to do with the variable being studied, for example a blood sample gets damaged or a report is lost; missing at random, where missing data can be predicted from other measured variables, for example a student is away and does not provide exam results. This could be predicted from his illness, which is recorded. Missing not at random, missing data is related to variables not measured. For example, a low grading student does not put his maths exam results because of embarrassment, and embarrassment here is not measured in the dataset. The methods involved include deleting rows with missing values, dropping variables, imputing for continuous variables, imputing for categorical variables, prediction of missing values, K&N imputation, time series imputation methods, and lastly multiple imputation. Feel free to skip around in the video to the section which you want to watch. To start off nice and easy, one way in which we can delete missing data is by simply deleting rows with missing values. For any row that has at least one missing value, we delete it. So we delete the first row or first observation, keep the second, delete the third, and keep the fourth. This is a quick and easy method to implement. However, you may have a row that just contains one missing value, as the case with the first row, and this method deletes the entire row even if other variables have values, so you are potentially dropping a lot of useful information. Since the data is unlikely to be missing completely at random, removing rows like this can result in biased results. Another method in which we can handle missing data is by simply dropping columns or variables that contain more than a set percentage number of missing values. Let's say, for example, we set this threshold to 60%. In the following data set, we would keep the first variable, remove the second, keep the third, and keep the fourth. Again, this is a quick and easy method to implement. Some disadvantages, however, is that the variable dropped must be insignificant in predicting our variable, so x2 here must be insignificant, and this method can result in the loss of a possible feature that is able to contribute to the prediction of our target variable. So x2 here could be an important feature in which we are removing. Continuous variables can be imputed with either their mean, median, or mode. As an example here, for the mean, and if we have 4 values under the variable x1, where we have one missing value, we simply take the sum of the non-missing values in that variable and divide it by the number of non-missing values, which in this case is 5 plus 7 plus 3 divided by 3, which gives us 5. And so we impute 5 in the first observation. Imputing using the median, we order the non-missing numbers under our variable and select the middle number. In the case where there is an even number of non-missing numbers, we simply take the average of the middle two numbers. In this example, there's an odd number of non-missing values, and so the middle number is 3, and we impute this. Lastly, for the mode, we simply take the most common value, which in this example is 2. An advantage of this method is that it does not require the deletion of rows or columns, so we are preventing data loss. It is a quick and easy method to implement. Mean and median is limited to continuous numerical variables. Mean imputation can distort the relationship between variables and also decrease the variance in the dataset. Categorical variables can be imputed with the most common value. In the case where there are a lot of missing values for a variable, a new category can be made. For example, let's say we recorded favorite color. If we were looking at the most common value here, it would be blue. And so we impute that. The next case where we have more missing values, we can make a new category. And let's say this is undecided. And we can impute this new category under the variable favorite color. An advantage of this method is that it prevents data loss. We're not removing the rows with missing values. And it is quick and easy to implement. Imputing the most common category can introduce bias. Imputing a new category makes assumptions about the data. In this example, the person might not have a favorite color rather than be undecided. Another method which we can use is the prediction of missing values. First, we select which variables are significant in predicting our variable with the missing value or values by using a correlation matrix. So let's say, for example, x1 and x3 are significant in predicting x2. We use the complete data to produce a regression model. So we use all the data where there is x1, x3, and x2 available to produce a regression model. We use the built regression model to predict the missing values. We can use other machine learning models and feature selection methods to predict our missing values. An advantage of this method is that it considers the relationship between the variables containing the missing values and other variables. It provides a good estimate of the missing variable and prevents data loss. A disadvantage of this particular method, however, is that it assumes a linear relationship between our variables. Next, we move to k-nearest neighbors imputation. KNN imputation uses the k-nearest neighbors algorithm to predict missing values. The algorithm works by identifying and using k data points to make a prediction. The k data points are closest, or neighbors, to our data point with the missing value. If our data is continuous, we take the Euclidean distance as a distance measure. If categorical, we can use what is called Hamming distance. In this case, we are using the Euclidean distance. For categorical data, we use the most frequent class of the k-nearest neighbors as a prediction of the missing value. For continuous data, we use the mean of the k-nearest neighbors as a prediction of the missing value. In this example here, we have two observations that contain a missing value. That is the first observation and the sixth observation. We look at which points are closest to these two observations by looking at x1 and x3 where there is complete data. K equals 3 here, which represents the number of nearest neighbors. For our first observation, the nearest neighbors are highlighted in blue. And for our sixth observation, our neighbors are highlighted in green. We then simply take the average values of our neighbors as the imputed value. If x2 was categorical, we would take the most frequent class as our imputation value. An advantage of this method is that it considers the relationship between variables. Some disadvantages, however, is that it is computationally expensive and affected by outliers. Next, we look at time series imputation. The first method is last observation carried forward. Here we are imputing on T3. We simply take the last observation at T2 and carry it forward as the imputation value. Next observation carried backward, again imputing at T3. We take the point at T4 and carry it backwards to T3 as our imputation value. Lastly, we can look at linear interpolation, where we draw a straight line between our previous and next available data points. We then impute on this line at t equals 3. Last observation carried forward and next observation carried backward are both simple and easy to implement, however does not consider the pattern of the data. Linear interpolation, however, does consider the pattern of the data, but is not effective on seasonal data. Next, we look at multiple imputation. We start with a dataset with missing values. We then impute on the dataset a user set number of times, say m, to generate m datasets. Imputations are made based on the other variables without missing data and a random component. So we can look at linear regression with a random component. For example, we then analyze the m-complete datasets. This can be, for example, calculating the mean of a variable or generating a linear regression model for each dataset. We then pull the results of each analysis. For example, take the mean value of regression coefficients generated for each complete dataset. Some advantages of this method is that it prevents data loss and accounts for the uncertainty in estimating missing values. A disadvantage, however, is that we assume the data is missing at random, that the missing value can be predicted from the measured variables. Thank you very much for watching, and I hope you learned something new.